Okay.
Yep.
It's correct.
Yeah. And little bit of quickly the governance. Again, thanks to everyone who is supporting this program, and thanks to you all for joining this program as well. There's a lot of shortages, skill shortages in 5G. Coming together and learning together, and also bringing new people to learn this technology is going to have a tremendous advantage for all of us. A couple of things quickly I wanted to share with you all. This is the email address if you wanted to make a note of it. In fact, what I will do is I will share this in the chat. I kindly request if you guys can mute it. Why it is coming in black? Interesting. A minute. And the Microsoft Teams looks like they recognize the font color also. This is interesting. Okay, these are the two email address if you wanted to reach out. If you wanted to give some experience, your experience you wanted to share in this forum so we can all learn together, I invite you to do that. And if you wanted to contribute some donation, feel free to do it. It helps with the tools because this is a free program. It helps with some of the tools, costs, and so on. Moving on to the next one quickly. So why we are here, you can always go and look up our first session. It's in the YouTube. I will share it with you, the YouTube link. But just to give you a brief, we know that there is a tremendous opportunity in 5G, and it's going to help the economy to grow like anything. And this is going to open up a lot of job opportunities. If it's not only 5G and future 6G, right? So if we are able to upskill and learn ourselves, we can be successful together rest of our lives, right? At least for me, you guys probably will go through 7G, 8G. Most of you are here, much younger than me, but it's a right field to be in. Develop your skills for sure. And what we are going to do here is we are going to really help you guys to develop expertise and ecosystem. Two things that we are going to do. And when it comes to expertise, this particular session that we are going to do bi-weekly, we plan for 12 sessions. Today we are in the second session, is going to help you to build expertise. And with the help of our partners and sponsors and Wave Labs and everyone, we are also going to set up a lab which is going to help you to learn a little bit hands-on end-to-end. So our goal is to build the expertise. We wanted to do this 12 programs, 12 sessions, 1 hour every Saturday, starting last, this is the second session, in fact. Then for the ecosystem, we'll try to bring in minimum, right? A minimum one radio, worst case simulators or the real radio, and one simple BSS system, one simple orchestration system, and we'll try to bring all these things together. Some of our team members, some of the volunteers who's going to present, they're going to bring this together and they're going to show us the demo. Maybe we will get an opportunity to play around and learn. So that's what we really wanted to do: build expertise and ecosystem. And while we are going to do that, we got to choose something. So we decided to choose Magma, which is a open source that we will learn in rest of the 10 sessions that we are going to go through together. Okay. And last but not least, before we start our session today, I also want you to take these things, right? So you got to register every bi-weekly, right? It's not once you register, you are you can join the program. It's not like that. You got to register every bi-weekly, and the link is this. I will also send that link here. So this is the link that you need to go and do it. And in case if you are a little lazy to go and register every time, just copy this and keep this with you. Create your own calendar invite for the same time, and just click this link. It will directly bring you into this Microsoft Teams. Okay. This is awesome. And then last but not least, I also wanted to give you this link. We wanted to put this into our Wave Labs YouTube. Because of the technical difficulty, we could not do it, but in next bi-weekly, it will be there. For temporarily, what we have done is we have put this into the into this playlist. So please, those who did not attend the previous program, feel free to go and click this and learn what we learned together in our previous program. Is that all clear to everyone, please? So far, so good? All good, team?
Yes.
Awesome. So let's
Yes.
get started. So what I wanted to do next 15 minutes is set a stage so that from our next session, we will start learning Magma, right? And I know that we did a survey last time, and there are a lot of people who are new into this learning. And let's go through a little bit of basics to set the stage and understand the big picture so that you can start jumping into learning the exact Magma moving forward, right? So that's the thought process. So please ensure that you learn it and also you bring your friends, family, colleagues who wants to really develop their skills in this to come and learn it. And I'm very big fan of helping everyone to skill up and innovation up. Most of the people who knows me, they know me very well. I'm very passionate about it. Okay, so moving on. So these are the 5 topics that I wanted to really cover, but the goal for today is not to cover all the 5 topics. The goal is to at least minimum cover the topic 1 and topic 2 to paint a big picture, not to get into too much of details, but to paint a big picture, get enough into the details so you understand the whole ecosystem. And so when you jump into learning Magma, you know where you belong to in that whole ecosystem. It's very important, right? It's like this: when you live in this whole world, where do we live, which country we live, which city we live, which street we live, and which house we live, right? So it's important to understand the big picture, and then it will allow you to really understand and articulate where you live. And if you get lost somewhere in some location, you need to really understand which coordinates you need to give. So it's very important you understand the big picture and also understand where and what you wanted to do and how you wanted to develop the depth into what you wanted to do. So my goal today is to really help you guys to understand the big picture in the first 2 topics. And in our previous session, we kind of started with this very basic slide, just to, kind of wanted you to start thinking. I mean, this is how the world started, right? People started using some kind of, normal phones and big switches. When two people needs to connect to, there was an operator in between talks to both of these persons, connect manually. These are interesting things, right? And also we looked at how the phones started from crank phone all the way to devices and smart devices that we have. We kind of looked at that, and I kind of asked this question to you all. Do you guys really remember these things? Because these things are something that was taught when I was doing my engineering. I'm not sure how much you guys really remember this, but the message that I wanted, it's my intention is not to really put this and help you to remember, but the message I wanted to give you is whatever that we study and the fundamentals that whatever we learn, it will always serve as a foundation for you, no matter what, what age you are in, no matter what technology that you're going to work with, no matter what customer challenges that you're going to solve. These foundations that you learn is always going to help. That's why I just want to give this as an example here. In our college times, I basically took these things from some of the notes 20 around 27 28 years ago that I made. I always kept some notes, and I just took that notes and I kind of intentionally put it in here in the old format as how I had my notes. So this is what I learned at that time, right? Switching, transmission, signaling. But now if you map, nothing has changed, right? Even today, you have signaling, right? I explained in our last call, right? There is always a planning and execution analogy. If you map that to how the users get connected and talk to each other. So when I dial a phone number to Rob, let's say Rob or Mickey or someone in this call, Sridhar. So there's always some signals goes between both the parties, and the other party phone rings. So once he sees that the phone is rings, then he picks up, then the actual conversation happens. So until the ring goes, all the things is basically you're trying to reach him, right? Like a planning, you can think of analogy. And once you pick up, you're actually executing, meaning you're talking. So if you take that as a basic fundamental things, and if you compare to all that we learned in the past, we used to learn signaling, right? Signaling is the one that goes between two parties, and until the phone rings, and then once he picks up, then the actual transmission happens, right? The actual voice gets transmitted, and both the people talk to each other. So I'm trying to kind of share that with you in a way that whatever that we learned is the foundation is still applicable even in this modern world. Maybe we might do things a little bit different, and we evolved from normal coaxial cable to nowadays optical cable, but the foundation remains the same. There is always a network that is designed for signaling, and there's always a network that is designed for the actual voice that gets transmitted, and so on, right? And the network could be different network, or it could be the same network, but sliced it to do these two things in a different ways, time division way, or frequency division way. It doesn't really matter, but the concept is that there's always signaling. Sometimes nowadays in wireless world, it's called as control plane and user plane. That's the message that I wanted to give you guys, right? So ensure that you always remember what you learned. It's going to serve you not only today, for many, many years to come, because the foundation is always a foundation. What you build on top of that could vary, but the foundation never varies. In the same way, this OSI model, I know most of the guys nowadays, if I ask, they know I know TCP IP. They'll say I know that stack, this stack, right? In wireless stack. But if I sometimes ask, hey, do you guys remember what is OSI model? Can you really tell me all those 7 layers and explain me what each layer does? Most of them don't know. And I'm telling you this because I've done this practical exercise by myself, right? Um, so, but if you take a step back and think about it, all the modern stack today is mixed and matched and doing whatever it is supposed to do, and that is defined in this OSI model, more or less, right? So the message I wanted to really tell you is the foundation is very, very critical. Okay. And then the next thing is it's also important that we understand a little bit of the evolution. So the evolution is we started from that crank phone, and I went on. The one most important network that most of us used in our olden days, and even today, a lot of developing countries, even the developed countries, uses the PSTN network, right? Landline phones that we used to call it as. That also had an evolution, right? Before there was one line that was there between two people talking, then there is a separate signaling line, and then the media line, because they use the word signaling and media. Why? At that point of time they were serving only the voice call, and they, before they had just one line, like I mentioned, they splitted that line to the signaling and the media. Signaling will allow the user to ring the phone. Then you have the media, like I mentioned, which allows the user to speak. So the network evolved from a closed city to a country and cross country, and it evolved in a lot of technologies, from the basic TDM technology to the CAS technology to the common channel signaling SS7 technology. It evolved like that. And before, it used to be like I ring up, I dial a number, the other person picks up, and we speak, right? But then slowly you are able to see the who is calling, other person, whoever is calling, you are able to see his name, you are able to see his number, and then you are able to even you know, um, call a toll-free number without knowing who the destination number is, and those kind of things came up, as an evolution of the PSTN network. Those at that time called as AIN. It's not an artificial intelligence, which you call it today. It used to be called as Advanced Intelligent Network. So those were the evolutions of PSTN network. But the message that I wanted to give you here is that even in this network, there was always a signaling slash control plane and media slash user plane, right? And there was always an evolution that happened to from the basic call to some advanced intelligent calls. So that's what even today is happening, right? In every network that we do, or that we have worked on in the past, and we are trying to continue to do and learn in future, there is always the evolution, right? So that's the PSTN network. On the other side of the world, there was a data network, right, on the enterprise and IT side, and this is pretty much very well. We all studied in our college, right? Starting from mainframe to the personal computer, starting from basic copper line TDM to now we have a high-speed IP Ethernet, and we know how we connected two computers. directly before with wires. Then we used hubs, switches, routers. Then internet came into the picture, and the in olden days, if you got to learn something, the only way you can learn is from your guru, right? But now you can just learn it from your Google guru, right? So things changed, and one thing that always remained was the purpose, right? Even though the technology changed, everything changed. The purpose remained to connect machines, right? To get the information as fast as possible into your hands, right? And allows you to collaborate and allows you to communicate in one or other medium is the foundation, right? But the different technologies allowed you to do that foundation, and data network played a very critical role at that point of time. And what happened was when PSTN voice was happening and data network was happening, then I'm pretty sure you all would have heard of nowadays. Even today, I have a landline, but I don't have a landline, traditional PSTN landline at my home, right? I have a VoIP line because it allows me to call internationally over IP, and it is cheaper, right, than calling over TDM and over old technologies. So then what happened was in the data network, people started thinking, hey, voice network is making a lot of money. What can I innovate in the data network to do the foundation voice call? That's how this voice over IP came into the picture. The enterprises had IP PBX. Then the voice over IP protocol came into the picture. The big success of one of the protocol, I'm pretty sure you all know, is the SIP protocol. Even today, SIP is used as a protocol to make voice call over 4G network. It's called as a voice over LTE, right? And voice over LTE is nothing but a gradual evolution of voice over IP in the data network into the wireless network. Gradual evolution of the protocols that we were using, TDM protocol, Cictron protocol, to the pure IP protocol that we use today, which is UDP, TCP, SCTP at the transport layer, IP and other layers. So voice over IP kind of technology which allowed you to do voice over the IP and basically started to bring down the business of the PSTN, right? And that's what was really happening, right? Every time a new technological evolution comes, it tends to augment some of the old technology, but sometimes it tends to also replace the old technology. So now what we looked at was the PSTN network at a very high level, voice network, data network, and then the data network evolved into the voice network, right? Just like a storyline. Then you have two computers between different enterprises sitting across different cities, countries, or whatever. I mean, you need something that connects the globe, right? One device to another device globally. Normally, those networks are called as the transport network, right? And the transport, like you have a lot of cables under the sea that connects multiple countries, right? Those are all the transport networks. And even if you have in your home, assuming you don't have a Wi-Fi, you're living 10, 15 years ago, if you wanted to connect your laptop to your printer, you got to have a wire to connect it, right? So that's a local transport network, and Wi-Fi sometimes you can consider as a transport network that connects you, wireless transport network that connects different devices within your home. So, but the bottom line, the concept is that there should be some network that connects everything, right? So those are normally called as transport network, which helps you to transport things from one device to another device. As simple as that. It's easy to remember. And even these had evolutions, right? In the olden days, we used to transport only kilobits per data, but nowadays we can transport 100 gigs and 400 gigs of data. So those are transport networks, right? Just remember these names. These names are very important as we start to learn 5G and develop ourselves. So then what happened in those time was you had a voice network, you had a data network. There's no wireless at that point of time. Then slowly wireless came into the picture, right? 1G, 2G, 3G, 4G, and now we are talking about 5G. I'll keep the discussion of discussion of that wireless in the subsequent slides, but focusing on whatever that we have learned in the past. If you think about it at a very high level, if you wanted to provide a voice services, there was a dedicated network designed for that, right? You have a device, phone, you have an access technology that connects you to the core network, then the whole core network. Forget about the network, right? even the customer support, sales, marketing, um, fixing the problems, monitoring, everything was designed as one silo that was used to provide only the voice services to the users. A good network example is PSTN, right? Data network is another separate thing, built everything separately, VoIP and everything, and it was provided separately. One thing that I did not cover previously is the cable networks, right? We watch videos. It had its own standards, DOCSIS in olden days, right? And now it has got evolved and it had its own network. The whole system was put together to just provide the video services to your home, watching TV. So that is how it used to be, right? In olden days. Then what happened was convergence happened, right? Like why voice over IP is a convergence. Why should I spend so much of money and give it to the PSTN network operators who are providing voice services? Why can't I innovate that in the IP network and I can provide? Same thing, cable, right? I'm providing only the video. Why can't I provide voice over the network that I already deployed? Why can't I provide internet access on top of the network that I've already deployed? That was the thought process. Multiple innovation happened, and networks started to converge. So every player, whoever deployed voice network, started thinking, how can I provide video and data through that network? The person who deployed the video, he started thinking, how can I provide voice and data through that network? And this whole convergence started happening. And then a lot of different technologies came into the picture. I'm pretty sure some of you might know, some of you don't even remember this. UMA technology, right? And there was WiMAX technology. I mean, there's a lot of technology came into the picture, right? That helped to bring a lot of different things coming together and converging. And another biggest thing that you need to remember is that the service providers who have built all these different networks, they have invested the radio networks, whatever the networks that they have deployed, right? Let it be PSTN network, whatever that we have learned, data network, whatever. They have invested billions and billions of dollars. You can't just take it and rip away and go to 10G. It's not possible, right? So you need to ensure that you leverage the investments that they have done, and also they introduce the new technology and make sure this new technology and all the investments that they have done for the older technology works together, and they are able to continue to generate revenue and the return on investment for all the money that they have put it in the olden technology. This is also very important. You can't just invest billions and billions of dollars and then throw away the network. That's not going to happen, right? So that all these different reasons that I have explained brought together the convergence, and a lot of innovations happened together. And it brought cable, it brought wireless, it brought wireline, all the networks together. And application developers, it enabled an innovation platform for the application developers to build a lot of innovative applications and deliver on top of the network. Now, if you think about application for a minute, right? Uh, the richness of an application depends on the connectivity. So 10, 15 years ago, we were able to talk only voice. Why? Because the connectivity allowed you to transport the data that is required only to provide that voice service. Then we were able to do internet browsing, video, and all those kind of things. Why? Because the underlying network evolved and it had a capacity to transport that kind of a data. Bandwidth, right? It had a bandwidth and capacity to transport that kind of a data. Today, we are talking about downloading 8K video, 4K video within seconds. I mean, why? Because the underlying network is basically allowing you to really do that, right? So the application, innovation, and number of applications. Today we are talking about metaverse, right? AR, VR, virtual world, digital world. Everything depends on the how fast you are able to transport the data. And that connectivity plays a biggest backbone for the innovation of different applications that is existing today that will come into existence in future. This is a very important point that I wanted you guys to remember. I will pause here before we jump into the wireless network for any queries, comments from anyone. Today's goal is to ensure that we cover at least wireless, wireline basics and wireless basics, so we can jump right into Magma. And it's going to be a little bit hands-on stuff, right? Starting next week, we can do more of that. But you need to understand some basics based on our survey. That is why we are going through this. as a second session today. So I'll pause here for any questions or any comments. Let me see if there is any chat um, questions available here. So far, so good, guys. All good.
Yes, madam.
Yes. Yes, it's good. Thanks.
Perfect. Awesome. Awesome. Let's move on to the wireless networks, right? This is where, I'll take you through slowly, but as we go forward, it will become a little bit complex, right? Um, this video is recorded anyways, right? You can always go back and watch a couple of times, and you can also do your own research to learn because this 12 session 12 hour is not really enough for you to make you as an expert, but at least it will give you a foundation for you to further learn more and collaborate in the channel, right? So we will be sending you the Microsoft Teams invite to all those who have attended. Join into that Teams channel, and we will continue to learn throughout the year. And even during this 2 weeks break, we will continue to learn, and we'll continue to do awesome things together, right? Reach out to me if you know, and I can talk to you personally. Also, I can talk to your company to see how we can collaborate and upskill within your company, our company and everyone's company to really make sure as an individual and as a company we grow together, right? So that's the thought process. Now, having said that, as there is no further question, I'm going to jump into this wireless network. So just to set the stage, I plan to do this for 20 to 20 minutes, 20 to 25 minutes and 5 minutes break, right? Towards the end to kind of ensure that minimum that you understood what I wanted to communicate. Like I mentioned, it will start slow, gradual, but it will get into a little bit details, okay? But still, it's not too details in a way that um, it's going to be too complex, but it will get into some level of details. Okay, so let's get started quickly. So when you look at from the wireless network point of view, right? I'll give you like 10 seconds, 15 seconds to quickly read through this, and I will kind of explain this in a minute. And I wanted you to focus the words business-driven communication, business-critical and mission-critical communications, and some examples that are out here. This relates to what I kind of explained in my previous session. The evolution of the applications, the complexity of the applications, the richness of the applications, the user friendliness of the applications. It all depends on how much of data that I can transport for that applications to enable that, right? This is what I kind of mentioned previously. That relates to the technology evolution, right? So this kind of maps to that if you think about it, right? In 1G, we were able to do only voice call. In 2G, we were able to do SMS, and that infrastructure allowed you to transport data max up to 300 kbps, right? Then you had 3G, where we started browsing internet, but very, very minimum, right? And then we talked in 4G. Now we can actually watch YouTubes. Think about it. Will YouTube, can it exist in 80s and 90s? No, right? It's not possible. And today, in the age of 2010s, it existed. Why? Because of the connectivity, right? Otherwise, that YouTube, there will be no business called YouTube, right? Or there will be no business called Facebook or anything else if there was no internet introduced in 3G, right? So it's all related if you think about it. Okay, and 5G is unique in the sense, right? If you look at from 1G to 4G, the technology evolution, it is always designed to connect people, but 5G is designed to connect not only people to people, but people to machine and machine to machine. And when you talk about people to people, you talk about voice, internet browsing, video calling, and things like that. But when you talk about people to machine and machine to machine, you talk about a lot of things, right? You talk about if you don't communicate what mission is asking, sending message to another mission, it could take bad decisions and it can harm the production, or it can even sometimes harm the human lives, right? Like for example, if you're not able to communicate a critical message for the traffic control, air and train control, and power grids, autonomous robots, which is helping the old age people. I mean, it can cause harm to the people as well, right? So the communication that is going to enable these kind of mission critical and business critical applications has to support the infrastructure that is low latency, right? And it can connect millions of devices, microseconds of low latency, and there's number of things that it needs to support. It has to be built for it has to be ground up built for those use cases, right? And the 5G is built for that. And the 5G is standards are defined and architected from day one to consider, right? So that it can provide not only the business driven communication like voice messaging and email, but also provide business critical and mission critical applications. So that is why 5G is special and first step into a new world of number of things that we can do together, right? So that's the key message that I wanted to give you. Now, that's from the technology point of view, right? And I also wanted to share it with you that who gets benefit from that technology? It's the people like you and me and the companies where we work. That's what these are the two things, right? And a company, let's say if you are working in the manufacturing company, how do I manufacture autonomously so I can produce 100 cars compared to producing one car? Uh, if I do less autonomously or more manually, it takes a lot of time to manufacture the car, right? So the industries and the companies that we work for and the individuals are the one who gets benefited from all these different technologies. Now, when you look at from the company's point of view, there are so many different industries, right? You can actually go and look at CAICS, it's the industry classification code, and the it's a global industry classification code. It kind of classifies the industry into multiple blocks, sub industries, sectors, industries, blocks, and in different ways. And what the message I want to give you is that every industry that you see, right, has its own use cases, and for every use case that industry needs to do, requires some foundation, right, some connectivity to achieve that. And dependent on the maturity of the connectivity, the industry gets benefit on applying different applications and the use cases that they wanted to do, so they can build an autonomous industry, right? So that's the key message that I wanted to give, tying back to what I said in the before. So in industry, these are all some of the industry eras, right? 1.0, 2.0, 3.0, and 4.0. The point here is that every era, the time period, whatever the technology that was available allowed different industries. Let it be a manufacturing industry, let it be a retail industry, whatever industry, right? The different technologies that were available at different time period allowed these industries to evolve, become more productive, become big, and grow themselves, right? So that's the key message that I want to give. And with 5G, with all the different technologies that we have, and the foundation of having 5G, which can transport the data requirements, all these different technology requires, and latency requirement and capacity requirement, there is a lot of innovative use cases and applications that we can build to solve customer problems. Okay, so that's the key message. Now, the other key message that I wanted to give is that uh, as a big picture, right? In any industry, if you jump into, or any products, platforms that you wanted to build, you don't build it using one tech stack, right? You got to have a broad understanding of multiple things that come together to build your products and platforms and solutions and use cases. This is very critical. So no one product is built using one tech stack. No one product is built using one technology. There's multiple technologies that come together to really build a product and provide a solution. Take, for instance, our phone itself, right? There is a hardware involved here. There is a lot of programming languages. If it is an iOS, C Sharp, and if it is Android, Java, right? And it's got a lot of technologies embedded in it, right? 5G, 4G stacks, sometimes AR, VR stacks, and things like that, right? So any product, tangible, non-tangible, end-to-end product platform, it requires multiple technologies that comes together to build the product. So it's very important. That's why you have to understand not only just the 5G, but also how 5G enables different technology, how different technology together with 5G and different architectures and interfaces like cloud, right, edge computing, different programming languages, tools and frameworks, all these different things that comes together to really make your product and solutions that can solve the customer problems. You got to really understand this big picture. At least, in this last in this particular session, in addition to learning Magma, we will also make sure that every different technologies at least are introduced, so you are able to connect and understand the big picture. That's the key message that I wanted to give you at this point of time. So now moving on, talking about 5G, right? I already kind of mentioned it, designed for connected industries. So up to 4G technology, it was mainly designed for person to person, but then it also evolved. They tried to evolve the 4G technologies. I would say they tried to augment the 4G technologies to support some of the connected industry use cases. But the reality remains that you can stretch only to an extent if the foundation is built for a purpose, not for a different purpose, right? So that the limitation you will hit soon, and that's what really happened in 4G technologies. And even today in 4G technologies, you can still serve multiple use cases for the connected industries. Even the older technologies you can serve like Wi-Fi and so on. But depending upon the use cases, you choose the right technology. But the 5G technologies is ground up built to cover most of the grounds, so it can be used for the multiple different connected industries. And three important things that you need to remember is the 5G is designed to provide high throughput, meaning transport a lot of data from one place to another place within shortest period of time. Very simple way of explaining, right? And then the second reason that it's been defined is to ensure that when a message is sent out from one place to another place, it reaches in a microsecond, right? And it doesn't delay. Think of a remote surgery. You don't want it to delay. Think of robot as trying to put different pieces to build a car. You don't want it to delay. Then what happens? It will start putting a door before putting a seat. You don't want to happen that, right? So it's low latency is very, very important, right? And then when you wanted to connect nowadays IoT, think about it, billions and billions of hundreds and billions of devices. If you look at people, we are just 6-7 billion, right? And when it comes to connecting device, you can connect hundreds and thousands of billions of devices. So you should have massive connectivity to really achieve similar use cases. So the 5G is built ground up for that. Okay. Another interesting thing that I wanted you to focus here is that every technology will result in at some point of time you need to go to the next technology, and it's going to happen. So the other day I attended a session where I listened to Nokia Bell lab president. His name is Thierry. Last name, sorry, I forgot. He talked about enabling working together with NASA and enabling communication in the space. Can you imagine that, right? How can we leverage the technology that we have today and enable the communication in the space? When people are there in the space, they can talk to each other, and future mission talk to each other in space and things like that. But the difference is the technology is the same, right? But the difference is how you make it is different, right? So the temperature, the mechanical enclosure that you put, and all those things are different. Right, so that's an interesting story. I wanted to say that why, because I want to connect to this particular slide here. Every technology has its limitation, right? Now, let's say Wi-Fi is good, but when it comes to latency, throughput, Wi-Fi is good. When it comes to latency, reliability, and your use case demands that, you don't probably want to put Wi-Fi. And some of the challenges are solved in Wi-Fi 6 and Wi-Fi 6E variants, but you got to, depending upon your use case, you got to really select which technology that you wanted to use. But end of the day, the message I want to tell you is that as the evolution comes, you need more bandwidth, more reduced latency, more device you wanted to connect, and sustainability is also very important. It's a very big topic. I don't know how many of you have heard of this. It's not about you invent, right? It's about how green you invent. You don't want it to make your planet really polluted, right? For a number of reasons. So sustainability is also very good topic. How can I build something that is green, right? It doesn't really cause any harm to the earth that we live, right? So this is also a very big topic, right? So you got to ensure energy, you got to ensure latency, you got to ensure user experience, you got to ensure throughput, and this is always going to grow. And another important thing I wanted you to understand is the intelligence. This I have said it in multiple times. Whoever has listened to my previous sessions, or any other sessions, whichever I've spoken, um, any product, platform, solutions, use cases that gets built, right? What we are trying to really do is we are trying to really bring the physical world, like sensors and everything, into the digital world, and bring the human world into it, like cognitive experiences and things like that, right? And solve the customer problem. This is what we are trying to do, end of the day. So the intelligence is going to be key. In addition to throughput, latency, and we also envision that the future is going to be a connected, intelligent network, connected, intelligent industries. It's able to make decisions, right? Decisions. So obviously it has its own positives and negatives, but the world is going towards that direction. So the 5G today supports X amount, and 6G is already targeted. I just kind of said, right, 150 terabytes per second capacity per kilometer, right? I mean, yeah, and then device density. Today we are talking about 1 million devices. We're going to have 10 million devices per square kilometer. I mean, this is going to continue to evolve. The more foundation that we evolve technology-wise, the more innovative application is going to come in, and which is going to make our life more easier and sometimes more lazy, right? That's also critical for us to understand. So end of the day, now jumping into a little bit of details, and we will jump into a little bit more details for next 10 minutes, is that, see, what is the motivation for 5G? I said it's for the connecting number of different things, creating user experiences, and bringing in new services. And bringing in new services is not just for 5G, right? Every technology will bring in new services. But in nutshell, there are certain things that were kept in mind when the 5G was defined. So they want to make sure that it supports all the different types of use cases that I talked about, right? That involves high throughput, high capacity, and low latency. And you don't want to design this in a way that you get rid of your old networks, right? You also have a way to ensure that it kind of works with the old network. And the most other important thing is it want end of the day, this technology is also looked at in a way that they wanted to reduce vendor independence, right? So they don't want to get stuck with one vendor. And the operators who are deploying this 5G network, they must have a freedom so they can pick and choose different things that they need in a la carte way to build their network, depending upon different use cases that they wanted to serve, not only towards people, but also people to machines and machines to machine. Disaggregation was big. And they wanted to define this in a way that not traditional way of defining the 5G network, but it's more service way of, like, internet way of defining the network. That's another way of explaining it, right? Traditionally, if you look at it, telecom networks had all these different protocols, right? SS7, Sectron, call it, IUUP, IUCP in 4G technologies. It's number of different types of protocols, stacks are involved, right? But if you look at in the internet world, it's pretty straightforward. IP, and it's all service-based architecture, HTTP, APIs. So they wanted to kind of, and that's why you see here in the data world, in the internet world, there's a lot of innovations, right? So they wanted to bring that also into this, disaggregate, vendor independence, service-based architecture. And they want, because the 5G network supports multiple different use cases, you wanted to ensure that you are able to provide 5G network for different types of use cases and able to build the network for different types of use cases. This is also very important. Why would I go and spend a lot of money and build a network for low latency and provide that network for a voice service, which requires only 64 kbps? It's more than enough to transport the voice. And even nowadays with the lower codecs, you can even transport the voice for single digit kbps. Why would you deploy and develop a network that you would use it for somewhere else, right? So There is a lot of flexibility in the standards are considered to do that, right? One of the concept is called network slicing, meaning you build a network with a lot of different resources, but you allocate the resources that are required, call it as a slice, end-to-end network slice for particular use case. So you build a big network and pick right resources for, let's say, connected cars. When you build you pick right resources that are required for voice service. You build a right network resources for video services. So those are the different things that were kept as a main thought process to build a 5G network ground up, right? So that's the that's what I wanted you to remember. Now, 5G network is not one technology, right? It's an amalgamation of different technologies. So one of the topic that we will be talking in the subsequent session is technologies like NFV. How does it enable 5G? And all these different things that we talked about, virtualization, containership, analytics, AI, AR. How does all these different things can help us to not only build an application and transport that application data through the 5G network, but also use those technologies to build the 5G network, maintain the 5G network, and deliver the solid 5G network to the users of it, right? And the industries, whoever is using that 5G network and deploying the applications. So it's two ways to think about it, right? One way is 5G network is an enabler for you to build different applications using different technologies. The other way is how do I use all those different technologies to even build the 5G network and run this 5G network more effectively. I'll give you an example, for instance, right? I can monitor the 5G network using AR. I can use technologies like AR, VR to kind of visualize how the 5G network is. And I wanted to provide this new service. What can I do in this 5G network to make this 5G network better to provide that service? I can use that technology to even build a better 5G network. I can use AI to predict what's happening in the 5G network and take corrective actions before something bad happens. So it's not only about I use these technologies to build an application to transport that application through the 5G network, but also use those applications to build, run, monitor, deploy, and enhance the 5G network as well. It's the connection that you need to really understand from your point of view. Moving on to the next step, right? Cellular network, right? So if you look at cellular network, understanding a very high level big picture, right? So you have a different devices in the left, and then you have a radio. So from the devices to the radio is wireless, right? And after that, pretty much it's all wired. But there are options where you can even have wireless using microwaves for quite a distance, right? But not obviously if you wanted to connect end to end, you can do that. And there is an option nowadays. You know that satellite. I'm not sure how many of you guys have heard of low LEOs, right? Low Earth orbit satellites. Now, Starlink is one of the company, and there's a company called AST Science. And even in Canada, there is a company called Kepler.Space. You should actually go and look at those companies, right? So they are building the low Earth orbit satellites that can transport the data, right? In that case, it's pretty much wireless between two locations. And it can also have a situation where it transport wireless between two locations, and from the destination location to another destination, you can still transport through wired, right? But the point I'm trying to make is there are different devices that you have that connects to the radio, whether it is a radio that is installed in every buildings that you see when you drive the car, or whether it is a satellite. Then you have the actual radio access network, right? Which is called as in olden days BTS, and nowadays for 5G it's called as G Node B. Because we are focusing on learning 5G, I'll just talk from that point of view. 5G radio is called as G Node B. Then you have, like I mentioned, the transport network in the previous sessions. So then you have a transport network that kind of connects all these different pieces, right? Whether it is a wireless transport or wired transport, you have that. I will show some additional sites in the subsequent sessions. And then you have a core network. Then you have billing and operating system that OSS that it ensures the network operates well. It's called as an operating support system. And then you have a BSS, which takes care of, it's called as a billing support system, which allows you to run your business, like allow your user to come and buy the SIM card from you, give them the SIM card, billing, accounting, and when they create a problems, trouble ticket, supporting them, and going to the house and fixing the problems. So those are all falls under the BSS, and OSS is kind of monitoring the network and making sure everything is running fine. And if you use the AI technology, predict and fix it before it happens, like I mentioned. So end of the day, the network, whether it is 1G, 2G, 3G, and 4G and 5G, you have devices, you have radio, then you have core network, then you have applications like BSS, OSS, and even more advanced applications that makes up the whole network that connects everything. All these different pieces are connected through the transport, and this is the whole cellular network that you have to understand big picture, right? Now, having said that, big picture, right? So let's start from 2G and 3G. So, if you look at access, right, just remember 4 words for simplicity. You have devices, let's forget for a minute, and the devices connects to your radio network, right? It's called as an access network. So in 2G and 2G network, the access network was called as BTS and BSC. Together, these are access networks. But the message I want to give you is that these are all the different devices or equipments that were available, and all these different equipments were talking, they are connected, right? And each of these connections are called as interface. And the interface has its own name, and interface has a stack, a protocol. So it's like an English language, right? I'm speaking in English and you are understanding what I'm speaking and you're listening to what I'm speaking, right? And you're able to understand what I'm speaking. Likewise, if this device, BTS device, has to understand what BSC is saying and vice versa, they both have to talk using this particular protocol, that protocol stack that is supported. That's sometimes called as an ABIS interface. So the intention is not to go through all these interfaces, and intention is not to go through all these devices and explain you, but the intention here is that you have an access network, right? And in this case, it is BTS and BSC. These are the access networks, and these different equipments are connected through different protocols. Then you have a core network. So the core network, in this case, it's called MSC, SGSN, and GGSN. I will let you to go and Google and learn what it is. But these are the 3 pieces that are core networks that allows you to allows you to connect different users through the access networks, authenticate them, and allow them to speak with other users. Simple, at a very high level, or allow them to browse the internet, or allow them to make a call from the mobile phone to the PSTN. So that's the thought process that I wanted to really leave it for today. That's for the 2G and 2G network, right? Now in the 3G network, the reason I put this together, you would realize that the concept and foundation is the same, but it is done in a different way. And the new technologies allowed you to support multiple foundational enhancements like throughput and so on. So a number of applications were getting deployed, right? So for the 3G, the same thing, right? The radio, the new radio, it was called as Node B. And this Node B and RNC, this whole thing became the access network. And this 3G, we used some of the 2G and 2.5G network nodes with additional enhancements to provide internet services. You remember 1G was only providing the voice, and 2G, 2.5G was providing SMS, and 3G was providing the internet. But the bottom line, it's the same thing, right? Now, if you go to 4G, it's the same thing, right? So they called it as in 4G G node B, and they introduced new core network elements like MME, S gateway, HSS, and P gateway. I will explain what are these in our next session before we get into the Magma portion of it, right? But what's more important is for you to understand that there is a radio network. In this case, 4G, it's called as E node B. And then in this case, there was no RNC and BSC. They said, hey, you know what? I don't need this BSC and RNC. I'm going to bring everything together and I'm going to create it as an E node B. Then they brought in with the new name, MME, S gateway, P gateway, which actually does the same thing as SGSN and GGSN in a better way. End of the day, it allows you to browse the internet. And they brought in IMS. It allows you to do the voice call through this S gateway, P gateway data network, it's called as. But the bottom line that I wanted you to understand is that it also had a radio network. It also had a core network. Then 4.5G, this lot of enhancement happened to now. Why to have a big macro cell? Why can't we have small cells that can cover interiors and the area where you need a smaller coverage? and still provide a higher throughput than what macro cell can provide, or equivalent, or in some cases higher throughput than what macro cells can provide? And how can I increase the different, I can bring in different use cases to support these, right? So those were called 4.5G. And in each of these evolutions, right, as you see, the interfaces names are different, and the protocols that are used within these interfaces are also evolved, and it was different, right? So all these combined together really help you to achieve from normal voice call to the connected industries use cases over 4G and even on the 5G network, which we are going to learn moving forward. Okay, so now this is going to be my last slide for today. This slide I wanted to really share here is that, again, in 5G we have the macro cells, and we have a small cells that you can put it in the enterprise and inside. Then you in 5G it's called as instead of 4G it's called as E node B. In 5G it's called as G node B, right? And like I mentioned, the radio access network in from 3G to 4G, they kind of brought BNC, RNC into this eNode B. In 5G, they splitted multiple access network architecture into multiple different names like DU, CU, RU, which we will be learning moving forward, right? But understand at this point of time that in 5G network radio, you have an option to build it as one. It's called as an aggregated radio, and you can also have an option to split different functions within the 5G radio into number of different smaller functions, and it's called as a disaggregated radio. Then in 5G, they also introduced a lot of core network functions: AMF, AUSF, and SMF. SMF, UPF, and number of other functions we'll be looking at when we learn Magma in our next session, right, in biweekly. So this is the core network, right? So, but the message that I wanted to really give, taking you through the journey from wireline basic fundamentals to the wireless basic fundamentals, is two messages that I wanted you to take it away for today, right? One is the technology evolved, and it provided us the connectivity provided us with a lot of foundations that allowed us to deploy and deploy number of applications, rich user-based applications that allowed us to take advantage of all the benefits that we are enjoying nowadays, right? At sitting at home as such, right? That's the one key message that I wanted you to remember. And another key message that I wanted you to remember, because from the third session onwards, we will get into the details, is that there is an access network, radio network, right? And there are devices, then there is a core network, and there is a transport network, and all these different types of networks that comes together to help you to browse internet, connect to people, and so on. Okay, and all these different networks has different equipments inside, and each of these equipments has its own purpose to be there in that network, and different equipments are connected with different equipments throughout this radio access transport, and each of these connections has its own language that these two equipments talk to each other. It's called as a protocol, and it's called as a protocol stack. All these things we will get into the details in our subsequent sessions, right? And finally, I wanted you to remember that 5G is a technology that is unique because it supports number of different types of use cases. So there are number of technologies that works together with 5G, right? Like virtualization, I call it as an adjacent technologies, right? We also have to learn those adjacent technologies to really understand the big picture of 5G and become master in 5G, which is and build expertise in 5G, which is what this program is intended for, right? I will pause here. I know that I went a little bit overboard 2 minutes. I always respect the time of you guys, but I'll pause here. Hopefully, it kind of gave you guys a very basic foundation. And the goal for our next session is we will have a mix of session, right? So we will get into the details of architecture of 5G. It's that now you understand the foundation. Now we'll get into the depth of 5G, meaning what is the transport network 5G transport network in 5G means? What is radio network in 5G means? What is core network in 5G means? And then within core network, we'll get into the details of interfaces and protocols. And then we will introduce Magma, how this Magma relates to all those things that we have learned. And then we will continue with learning the architecture of Magma, deploying the Magma, connecting it with radio. By end of the session, right, we will have an understanding of how this whole thing comes together and works together. So that's the thought process, everyone. And with that, I will pause for any questions anyone may have. And please remember this particular video, we will again post it into the YouTube. I sent you the links of the YouTube. Do not forget to copy that, please. So here you have the support sponsor, and do not forget to copy this decoding 5G.Zone Eventbrite to go and log in. And also do not forget to copy this decoding 5G.Zone in case if you wanted to join directly into this Microsoft Teams in next week. Okay. And also do not forget to copy this YouTube link. So I'll give a couple of minutes to you guys to copy those, and please feel free to leave. And if anyone has any questions, stay back and ask questions. I will be happy to answer.